Hello. So today I am actually just going to be going through some questions. Grade 9s, of course. As always, we'll have a mix of what we will probably do in geometry, and also we'll see how far we can go. So I have a few questions here. As you can see here, we are saying in the diagram below, prove that triangle KLM, and we have this symbol here. This symbol stands for congruency. We are told that diagram below, prove that triangle KLM is congruent to triangle KNM. Now hopefully for all my live viewers that are here, we all by this time, at least at this point, we should know that there are four cases of congruency. We have side, okay, which we can prove. We have side, angle, side. So important that whenever we prove side, angle, side, the angle concerned must be the included angle. Then we have right angled hypotenuse side, and then lastly we either have what you call angle side, or sometimes referred to as side angle. Okay, so it's always important, guys, that one of these four cases be proved whenever you are wanting to prove a case of congruence. And the symbol that they use for congruency is these three horizontal lines. Okay, so if we look at the diagram again, we are asked here to prove that triangle KLM is congruent to triangle KNM. So in order to prove the congruency of these two triangles, we are just going to go to the two triangles and check what is the information that we have. So in triangle KLM, there are this line and that line. That line indicates equal sides. So for triangle KLM, we can see that for triangle KLM, KL, which is going to be my first statement, KL is equal to who? To KN. What is the reason for that? Well, it is given. Okay, and so I've just identified my first pair of sides that are equal. If you look at the order of the letters KLM, KNM, I have just written down that KL, which is the first two letters, is equal to what? KN, which is the first two letters for the other triangle. And rightfully so, KN here and KL both have these symbols to indicate that they are equal. So I say they are equal, that is given. Furthermore, LM is equal to what? To NM. Why? It is also given. And if you look at the order of the letters in the triangle, LM and NM feature at the end. Okay, they are the last two letters in the triangle. And funny enough, you can see that LM is equal to NM because of the symbols. There's two of them, so therefore that means that pair is equal. The reason it is given. Lastly, this KM, the side KM, is a side that is common for both of these triangles. KM is a common side for triangle KNM, and it is a common side for triangle KLM. They share the side, both of these triangles. So we can say that KM is equal to KM. In other words, the first and last is equal to the first and last. The KM is equal to KM. And our reason for saying that is we say common side. Guys, I've just identified how many pairs of sides being equal. This is my first pair. This is my second pair. This is my third pair. Then I can go and say, therefore, triangle the order according to what I was given. KLM is congruent to triangle KNM. What is the case of congruency? You must write the case of congruency at the end. S, S, S. Side, side, side. How many marks? 4 marks. 1 mark for my statement and reason. 1 second mark for my statement and reason. 3rd mark for my statement and reason. And then my 4th and concluding mark for my conclusion and the reason. The case of congruency must be written for the 4th mark to be awarded. So you have 1, 2, 3, 4 marks beautifully given for you. Okay, let's move on to another question. In the diagram below, AB is parallel to PQ. Okay, here is AB, here is PQ. We are asked to prove that triangle ABO is congruent to triangle PQO. So we need to prove the, no, not congruency, similarity. This parallel, these 3 vertical lines are lines that speak about what? Similarity. I want to make a point and some notes on the side. I'll come back to this question. Guys, the 3 lines are lines that indicate similarity. What is similarity? Similarity is if 2 shapes are equiangular. In other words, they have equal angles and the sides are in proportion. The what? The corresponding sides are in proportion. In other words, they are in the same ratio. If that is the case, then we say that the 2 shapes are similar. So we then say that similarity is when shapes are equiangular. And if they are equiangular, we know that the sides are in proportion. In other words, there is proportional sides. I want you to understand this. Similarity means equiangular. Equiangular means the sides are in proportion. All right, guys, remember that similarity can also be applied to other shapes, not just triangles. But in the grade 9 context, you guys are exposed to similarity in triangles. But please also remember that any other shape, you can be able to also see similarity in other shapes, not just triangles. But of course, in grade 9, you are learning specifically about triangles. So it's very important to understand that similarity means equiangular. Equiangular means similarity. Just like equiangular means proportion and proportion means equiangular. Proportional sides means similarity and similarity means proportional sides. These are very important to understand. So if you want to prove similarity, there are 2 ways in which you can prove similarity. You can either prove equiangular or you can prove sides in proportion. You can either take this path or you can take this path. But we must always check the information that we have in order to either prove equiangular, and our case is always going to be angle, angle, angle at the end. So we must prove that three corresponding angles are equal for the two triangles? Or you must prove that what? The sides are in proportion. The three corresponding sides are in proportion. So if you can prove one of these three, then you can conclude and say that the triangles are similar. It's one of two ways. So let's come back to the diagram. Guys, if you look at this diagram, I want us first, before we jump into and answer the question, to check what we have in the diagram. So we are told that in triangle, in the diagram below, AB is parallel to PQ. Then for triangle ABO, here's triangle ABO. There's 4 centimeters, there's 5 centimeters, there's 6 centimeters. This triangle has all three sides. Then for triangle PQO, this triangle has only side OP. That's the only side it has. We don't know what OQ is. We don't know what PQ is. And we are asked to prove that triangle ABO is similar to triangle what? PQO. Now, can I prove that the triangles are similar using the sides? Can I do that? That's my question to the people that are listening. Can I use the sides of the triangle to prove that these two triangles are similar? Can I do that? Can I use the sides? Do I have enough information to be able to use the sides to prove that the triangles are similar? Do I have enough information to use the sides of the triangle to prove similarity? Now, Ari says yes. It's Your Girl says yes. Other people, it seems like, are silent, but Ari and It's Your Girl are saying yes. Now, guys, I want to say to you, and I want to say it to you so that you understand me well. You cannot use the sides to prove similarity of these two triangles. I repeat, you cannot use the sides in order to prove similarity of the what? Of the triangles. Why? Because, listen to me. Remember, what did I say? I said, if you want to prove similarity, there's one of two cases that you can use. You can either prove that the sides are in proportion, or you can prove that the angles are equal. But you need to prove three angles that are corresponding are equal if you want to use equiangular to prove similarity. You must have that information. Or if you don't have this information for angles, you must prove that the sides are in proportion. But you must have the information for the sides. Now, what you are seeing here is that you have information for this triangle. All three sides are there. But then this triangle is missing information. So I'm going to say to you, dear grade 9 learner, you cannot use the sides to prove that the triangles are similar because you are missing PQ and you are missing OQ as well. We don't have what the side is equal to. We don't have what the side is equal to. And because we still need to prove that the triangles are similar, we can't find X yet until we prove that the triangles are what? Are similar. So we are going to say we can't take the option of proving sides in proportion. Why? Because we don't have enough information for the sides. So let's then move on to what? To angles. Can we prove that the angles are equal for the triangle? Can we prove using equiangular? Yes, we can. Why? But sir, someone's going to say, but sir, I don't have any angles that are given to me. How am I going to use equiangular? Wow. Well, you've learned a lot of things by now. So let's go. Let's look at this triangle. Triangle ABO and triangle PQO. What do you see, guys? Do you see this angle and this angle? What do we know about those two angles? Can someone tell me? Angle BOA and angle POQ. Angle BOA and angle POQ. Aren't those two angles equal? angle POQ and angle BOA, aren't those two angles equal? What is the reason for them being equal? Yes, guys, please. Now, as I always say, you must write the reason according to that document that is called the acceptable reason document. I've been emphasizing this in my live sessions so many times. If you guys want to really become maths, amazing math students, make sure that when I'm live, you are here, because I will unpack for you. Because if you want to be solid in grade 9 and then 10, 11, and 12 in maths, I'm telling you, if you're here, you will know. So vert op angles equal, this is the acceptable reason that is in the exam guideline document, guys. This is vert op angles equal. Okay, now what else? These two lines AB and PQ are parallel, aren't they? So there are relationships that exist between parallel lines. Okay, and I'm sure you guys can see. What do we know about this shape that we are getting? We are getting the Z shape here. Angle BAO is equal to which angle? Angle QPO. Can you see that? Angle BAO is equal to angle QPO. What is the reason? Alt angles. Guys, whenever you write these reasons, you must write them correctly. Alt angles, for short, you write a semicolon. You must state the lines that are parallel. AB is parallel to what? To QP. If you don't state the lines that are parallel, your reason is incomplete. Angle BAO is equal to angle what? QPO. There, middle letter denotes the angle. There's the reason. Then lastly, what else? This angle ABO, is equal to what? Can you see the angle that it's equal to? Can you see the angle that it's equal to? ABO is equal to PQO. 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 What is the reason? Well, the reason is the same. Alt angles. Then which lines are parallel? AB is parallel to QP. Well, then I would say that what have we identified? Our first pair of angles, our second pair of angles, our third pair of angles. And I would say that for these two triangles, we have angle, angle, angle. So in other words, we can then conclude there is the order. Look at the order, guys. Look at the order. This angle A is supposed to be equal to angle P. Rightfully so. There it is. This angle B is supposed to be equal to this angle Q. There it is. This angle O for triangle ABO is supposed to be equal to this angle O for triangle PQO. The order is put in such a way that this angle should be equal to that one, that angle should be equal to that one, that angle should be equal to that one. Okay, and it is so because at least we do have the angles that actually we can actually find reasons for them being equal. So then we can conclude now and say triangle. We write the order as it has been stated. ABO is similar to triangle PQO. What is the reason? This is very important. You must write AAA for angle, 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 or you could write the symbols for angles, which is angle, angle, angle. And that is your case of congruency. I mean, not congruency, sorry, I keep on making the mistake. The case of similarity. 100% correct. Okay, any questions? I hope that's clear, guys. So similarity of triangles in the bag, just like that. Okay. So I've looked at a situation where I'm supposed to prove the congruency of triangles. You saw it. Okay, great. My beautiful grade 9s. Now similarity, guys. Case of congruency for similarity. Grade 9s. Do you see? Yeah, so it's just like that, man. Just like that. Nothing in it. Nothing in a day's work. I just want to conclude with this question. All right, I'll go to parallel lines, oh God. The next question says, calculate the value of x. Okay, I'll go to parallel lines, just wait. Calculate the value of what? Of x. The next question has to do with that. Just hang on, raw God. Calculate the value of x. Now, guys, let's go back. We need to calculate the value of x. Okay, we have just proven that the triangles are what? Are similar. Okay, so because now we know that the triangles are similar, we can then move on and say, remember what I said earlier on, similarity means proportion and proportion means similarity. So if we look at AB, because I've proven that the triangles are similar, I can then say the following. Similarity means proportion. So if you take AB, do you see AB? Let's write it down. And you take PQ, the first two letters of each triangle. I can say AB over PQ. That's a ratio. That's, that's a ratio. Okay, is equal. We'll take BO, the last two, and QO. We'll say BO at the top over QO. Okay. Then lastly, the first and the last. First and the last. AO over what? Over PO. These sides I can say now they are in the same proportion. Why? Because of similar, this is the symbol for similar, triangles. I've proven that the triangles are similar. Therefore, I can now state that the sides are in the same proportion, same ratio. Ratio means fraction. Make sense, guys? Now, remember, what do I want to find? I want to find x. Where is x? X is OQ. So I'm going to now choose two ratios to equate together. So if you look at AB, where is AB? AB is 4 centimeters. PQ, where is PQ? PQ, I don't know. This fraction I'm not going to take and use. This fraction, I'm going to say goodbye to you. You're not going to help me in any way. Why? Because I have AB, it's 4 centimeters. PQ, I don't know yet. So I'm going to say for now, I can't choose you because you have something that I don't know, which is PQ. So let's move on to the second fraction. What is BO? BO is 5 centimeters. Good. What is QO? QO is the X value that I want. So this fraction I'm definitely going to take. When I'm taking you, I'm going to use you. Let's go to the last fraction, AO. What's AO? AO is 6 centimeters. What about PO? PO is 12 centimeters. I am also going to take you. Choose two fractions. Right? This reason, guys, is so important. I've just proven that the triangles are similar. So therefore, I can say that the sides are in proportion. Goes back to my thing that says similarity means equiangular. Equiangular means similarity. Similarity also means proportion, and proportion means similarity. So therefore, because I have proven the similarity of triangles, I can say that the sides are in proportion. I write all three fractions. I state my reason, similar triangles, because I've proven similar triangles. Then I choose two fractions. The fractions that I'll be able to use. What's BO? BO is 5. What is QO? QO is the X I'm looking for. What is AO? AO is 6. What about PO? PO is 12. This can be solved. In term 2 as a grade 9 learner, you did solve for X. So 5 over X is equal to 6 over 12. I'm going to solve for X now by cross multiplying. This 12 I will multiply with the 5. The X is going to get multiplied with the 6. So I'm going to now have 12 times 5 is equal to 6 times X. This is the same thing like saying, guys, what is the lowest common denominator? The lowest common denominator is 12x. Then you multiply both sides by 12x. All right? Yeah. But cross multiplying is just a short way of saying the same thing. So 12 times 5, that gives me 60. 6 times x gives me 6x. And then what do we do here? We divide both sides by the coefficient of x, which is 6. So that means I'm going to divide. If this is 6x is equal to 60, I divide by the coefficient of x, which is 6. And then that means x is equal to what? To 10. But remember, the unit is there. So it's 10 centimeters. So that means the x value is actually 10 centimeters. And that's how I'm able to find my answer. Guys, beautiful. So this question helps us to be able to really internalize the concept of similarity. Right? Sky4 Y01. This question paper is unfortunately physical. I'll make a plan, during the course of the day and try and find a clean one and take pictures, and then I will post it onto my TikTok page so that you can have it for your use. All right, I'm very sorry, but yeah, this is kind of like obviously a live session that I'm doing, yeah. Okay, let's move on. Let's look at this one. In the figure below, ABCD is a parallelogram. Angle A is x plus 50 degrees. Angle B is 2x minus 20 degrees. Calculate the size of x. State reasons. For how many marks? For 4 marks. So how would we do a question like this? We are told ABCD is a what? Is a parallelogram. And you can see there are my parallel lines. Hey, there they are. Because this is a what? It's a parallelogram. Then we are told angle A is x plus 50. There's the x plus 50. Angle B is 2x minus 20. There's the 2x minus 20. What do they want? The size of x. With what? With reasons. Alright? So, the person who was saying, please do parallel lines. Where are you now? Rock God, you must be able now to lead me. How would I find the value of x? Rock God, you are the one that's supposed to be here now and saying, say, this is what I see. Because you were the one that was saying, do parallel lines. There. Here are the lines that are parallel. What is the relationship that exists between these two angles in between these parallel lines? There are 3 relationships that we know in parallel lines. There's co-interior, there's corresponding, there's alternate. So which one is this one, Rock God? Okay, I see Koketo, your answer. I'm waiting for Rock God, the one who was saying, please do parallel lines, to answer in the comment section. I mean, this is the best time for Rock God to be answering. But if Rock God is not answering, then it means that he asked for parallel lines in vain. Okay, I see he's not commenting, or she is not commenting, because I don't see anything. Okay, very good. Knowledge is on point. Yes, the U shape. What do we know about the co-interior angles? Are those angles equal, or are those angles supplementary? In other words, do they add up to 180, or are they equal? Because there's always a misconception from learners that learners sometimes will say, no, they are equal. Some learners will say, no, they are supplementary. And they are confused. But you need to be sure. Think about you as the part where your armpits are situated. Right? Whenever your armpits stink,
Okay, if you extend your arms, parallel before you, your armpits are the place where, it usually stinks. So you need to add roll on. You need to do what? Add roll on to your armpits so your armpits can smell better. So in the same way, your armpit angles, these are your arms and these are your armpits. Okay, yes, your armpits. You must add something. You add the two angles together in order to get 180 degrees and solve. So please just think of addition. We are adding roll on. We are adding the angles to get 180. These angles are not equal. The problem with learners sometimes is that they think they equal these angles, but we add them so that they equal to 180 and we solve. Then our reason is important. So what we would have to do is say x plus 50 degrees plus 2x minus 20 degrees is equal to 180 degrees. Then please, your reason, guys, you must make sure that you write co-interior angles, but you must then state your parallel lines. Remember, the U shape is formed for the two angles. Where is the U coming from? The AD, the BC. So AD is parallel to BC. You must state the lines that are parallel. AD is parallel to BC. Okay, then from there, it's a matter of algebra. Term 2 work as a grade 9. You must then solve for x. So there we have it, x plus 50 degrees. We can remove the brackets. Plus 2x minus 20 degrees is equal to 180. We make sure that the x's are together. We make sure that the x's are together and the numbers are together. So x plus 2x, then we transpose everything else. 180 is joined by who? Negative 20, which obviously when it crosses over, he changes. You cross over to change. When you cross over, you change. Negative 20 becomes plus 20. Plus 50 becomes negative 50. Then we add like terms. What's x plus 2x? Hopefully, guys, you know what x plus 2x is. Otherwise, hey, that's where you lose it. X plus 2x is 3x. Right? There's my reason, guys. Kayanda. Very important, this reason. Co-int angles. For short, you state the lines that are parallel. AD is parallel to BC. I repeat. Co-int angles. Co-interior angles. Semicolon. You state your parallel lines. If you omit to state your parallel lines, then your reason is incomplete. You can't just write co-interior angles. You must write co-interior angles and you must state your parallel lines. Please, guys, you must state your parallel lines. If you do that, even in grade 10, you will be, if you are planning to do pure maths in grade 10, you will be fine. 180 plus 20 is 200. Minus 50, we know most. Then from there, we divide both sides by 3. X is equal to 1. Give 50. Give 50 degrees. All right, there it is. How beautiful. How beautiful is that calculation that we have just done. All right. Yeah. Hey, guys. Yeah. Right. So yes, rock God, just remember. So the U shape is co-interior angles. Remember. Let's see, rock God, if we can cover you somewhere else. Let's see if there's any other. Rock God, here we are. Look at this one, rock God. Huh? In the diagram below, prove stating reasons that AB is parallel to CD. Maybe rock God, before that, let's check this one out. Let's check this. Let's find the value of X, the value of Y, the value of Z. We have CMs there. I don't know. I don't understand what CM means. Okay, so here we are. X, Y, Z. Can you guys tell me? You can find any. If we want to start there, the lines are parallel, these lines are straight, okay, we can find who? We can find x. All right, if we find x, what's the value of x? Okay, these two lines are intersecting lines. X is equal to what? And what's the reason? Okay, then from there, we can find z. If we have x, we know what z is. Okay, if we have x, we can also find what y is. Even if we don't have x, we can find y, because 25 and y have a relationship. They are on a straight line. So these two angles added together give us 180. Now, you may find that there's many ways of getting to the answer. What's important here is your reasoning. Okay? What's important is your reasoning. You must make sure that the reason works. Okay? So SKK, I love it. Yes, indeed, x is equal to 25 degrees. Okay? It is. And your reason is 100% correct. Vertically opposite angles. X is 25. You guys are 100% correct. So for instance, I endorse the statement by SKK there. You know, I endorse it a lot. So very true. Okay, I think we can all agree with what SKK has just said there. X is 25 degrees. You guys are 100% correct. Whenever you get your answers, update your diagram, guys. Update it. Now you have this angle. You wrote x is 25 degrees. Vet op. The acceptable reason document says vet op angles equal. That's what the acceptable reason document says. Okay. Then you can find z. This is your z shape. You have x, this angle and this angle. You can see those two angles are between parallel lines. Your other relationship is alternate angles. So we can say z is equal to 25 degrees. Okay. And please, when we write alt angles, okay, we must then do this thing of stating lines that are parallel. You see, unfortunately, there's no letters here. So what I'm going to do for the person who's marking my paper, I'm going to write alt angles. I'm going to write a semicolon because I don't see any letters there. I'm not going to put in any because the examiner was not kind enough to put in letters for me. So I'm just going to say alt angles, and then I'm going to write parallel lines. You see, so that the person knows that I understand when I'm saying that the angles are equal. Yes, it's because of alternate angles, but it's because of the lines being parallel that I say that the angles are equal. You see? Yeah. Yes, Londi. If you have, sorry, this is actually y. If you have the angle, if you had found the angle y using angles on a straight line first, because some people could go that direction, find the value of y using angles on a straight line. Remember, guys, this angle plus that angle, they complete a straight line. The protractor, they complete from here to there, from here to there. They complete a straight line, and these angles are adjacent. They share a common vertex. So these two angles added together. Yes, someone could say y plus 25 degrees is equal to 180 degrees. What's the reason? Angles on a straight line. Someone else could do that, right? They could. Someone else could take that direction. I'm just exploring directions here, just to show you that in geometry there's many ways to get to the answer. Then of course that would be equal to what? 155, right? Yeah. But someone else who said z is equal to 25 degrees, he updates. Okay, z is 25. Then he says that y plus 25. The one who said y plus 25 is equal to 180 degrees. You're 100% correct. You're using co-int angles. And remember, you must state the lines that are parallel. So the person who said y plus 25 degrees, thank you so much for the rose, Senator. Y plus 25 is equal to 180. You see U shape. You found z first. You see U shape and you say y plus 25 is equal to 180. You're 100% correct as well. So there's many ways to kill a cat, or there's many ways to getting to the answer. All right. So I love that many people here, we may not necessarily get the answers in the same way, but our ways may be different, meaning our reasons may be different for us being able to actually get certain values, and ultimately that helps us. For instance, someone else could have started and said 25, could have started by finding Z because they see the F shape. Okay, they say to start with, they don't start with X, they say Z is equal to 25 degrees. Reason, corresponding angles. Remember, this is F, top, we are equal. At the top of this parallel line, this angle is equal to the top of this parallel line, this angle. Y is equal to 25 degrees. Someone else could have said that. Z is equal to 25 degrees. Sorry guys. Z is equal to 25 degrees. Reason, corresp angles. Someone else could have started off the question that way. You would have been fine. Corresp angles. Then after that, you must state the lines that are parallel. Okay? So I hope you understand that we could have gone about answering this question in many ways. So yes, you guys are right. Y minus 180 minus 25 here, that means 155 degrees. Many ways to getting to the answer, guys. Many ways. It depends on what your eye is able to see. So if you've trained your geometrical eye to see the reasons, and to see the diagram, you visually can see, oh, for parallel lines, I can have F shape. If the lines are parallel, it means top on the same side, we are equal. This is corresponding. Or bottom, we are equal, corresponding angles. Does that make sense? Or if we see Z shape, this angle and this angle will be equal. You see? Vertically opposite, we are equal anyways. If we're saying Z shape again, there's another Z, this angle is equal to that one. You see? So basically, it's important. Then co-interior, U shape, we know that the armpit angles, that's where things stink. We add roll on, we add the angles, co-interior angles. And does that make sense, guys? So the relationships, we must know them. And when you know the relationships, guys, we cannot forget them. We must then be able to use them when we are given problems. Okay, I hope we are together. F, corresponding. U, co-interior. The sum is 180 for co-interior. Z, okay, alternate angles. The angles are equal. So for corresponding and alternate, the angles are equal. But for co-interior, the sum of the angles should give us what? 180. Okay, guys, I'm sure you can see this problem. They say calculate stating reasons the size of G, E, F. So they want the size of this angle. Okay, they want the size of this angle, grade 9s, the size of this angle. Okay, I hope that makes sense. So they are saying here, okay, not telling him, asking. No, that's fine. Guys, it's very hard for me to go live during the day because I'm at work during the day. That's the unfortunate part. So I try to do so in the mornings and any other time. So let's see, I just want to remind people here, corresponding angles, lines are parallel. Okay, so corresponding, top, we are equal if the lines are parallel, guys. That's why when you write your reason, you must write corresponding angles and must state the lines that are parallel. Okay, so top, we are equal, corresponding, or bottom, these angles. So that's why I call them the top angles. We are equal, but it must be on the same side. Top, we are equal, bottom, we are equal. Make sure this line is straight and those two lines are also straight. That's corresponding angles. The angles are equal. If the lines are parallel, my armpits, where it stinks, we are not equal here. The sum of these angles, when we add them together, gives us 180. These are co-int angles. You must always state the lines that are parallel when you are writing the reason for co-interior angles. Then lastly, we have N. I usually say it's also Z. It's also the funny Z. Look at the position where the angles are equal. It's here and here, here and here, and there and there. but the lines must be parallel. So we call these alternate angles. When we write the reason, we say alt angles. Guys, please always state your lines that are parallel when you are writing the reason. So if they have the letters there, let's say they have A, B, and C, D, then you go ahead and you say AB is parallel to CD. Okay? Yeah. So those that are writing today, guys, hopefully you can remember this. Okay? Fun. Okay? So corresponding angles and alternate angles, they are equal, but co-interior angles, the sum of those angles gives you 180. Your armpit angles, where it stinks, you add roll on, you must add the angles. You equate them to 180, you solve. Okay? All right. So hopefully we understand and we are okay. Okay? I know some learners, they even say, I know that the fun is for the parallel lines, and then obviously X, vertically opposite angles. Okay, this angle will be equal to that one, vert op angles equal, that angle will be equal to that angle, vert op angles equal. Okay, and then of course, we look at angles on a straight line. When we add these two angles, they give us 180 degrees. Okay, so yeah, always remember, guys. Now I'm coming back here. In the diagram below, DEG, where's DEG? DEG, so here this angle is 90. The box is there, right angle, 90 degrees, makes sense. DEF is 5x, there it is, 5x is there. GEF, this angle here, 3x plus 30. Calculate stating reason the size of GEF. Now guys, I'm sure you can see, in order to find the actual size of GEF, what are we going to have to do? We are going to have to make sure we first find the value of x. That's what we need first. Okay, so how do we do that? Guys, I'm sure you can see this angle plus that angle plus that angle. What are they completing? This angle, 3x plus 30, plus that angle, 5x, plus that angle, 90. What are they completing? A revolution. They are completing a circle. These are angles that are around which point? This point, that point, angle E. Therefore, we say what? 90 degrees plus 5x plus angles around a point. Or we could say angles in a rev. In other words, revolution. This is the acceptable reason that we have in the document. Angles around a point PT, or you can say angles in rev. So you must decide which reason is more palatable to you. But angles around a point is more famous for most learners. But these are the reasons that are stated in the acceptable reason document that is basically accepted nationally. So 90 plus 5x plus 3x plus 30 is equal to 360. Then we can solve. 5x plus 3x is 8x. We transpose everything else. 90 plus 30 is 120. So we're going to say 360 minus 90 minus 30. Then we say 360 minus 90 minus 30. So that's like saying 360 minus the number of people that are in my life. Okay, they just left, but it was 120 just a second ago. So 360 minus 120, that gives us, come on, I'm waiting. 360 minus 120 gives us, yeah, you said it, guys, 240. Okay, 240. Yeah, it can't be 140, Camille. Be very, very careful. Then we divide both sides by the coefficient of x. X is multiplied to 8, so we divide by 8. We use the inverse, the multiplicative inverse of the multiplication. We divide by, since 8 is multiplied to x, we divide by 8 to get rid of it. Then we are left with x is equal to 240 divided by 8 is equal to, you said it, 30 degrees. We didn't want the value of x. We were asked to find the size of GEF. Okay, we were asked to find the size of GEF. So we go back and say GEF is equal to 3. In the place of x, we substitute 30 in the place of x. because we found that x is 30. We substitute x in the place of, 30 in the place of x. So in the place of x, we substitute 30 plus that 30, this one. Then we solve 30 times 3 times 30 is 90. 90 plus 30 is 120. So angle GEF is 120 degrees. So always read the question, guys. Make sure when you read the statement, all the information in the statement is available in your diagram. Angle DEG is 90, that's there, the box. Angle DEF is 5x, that's there, I have it. GEF is 3x plus 30, it's there in the diagram. Calculate stating reasons the size of angle GEF. So GEF is given in terms of x. You see there's an x there at the moment, but they want the actual size, right? So what I need to then do is check what is the relationship that exists. Guys, whenever you want to know people, you must first ask what relationship do they have with something. So when you're looking at this problem, you must ask yourself, what relationship do these angles have together? So once you locate the relationship that the angles have together, then you can be able to answer the problem. What's the relationship? From here to there, from here to there, from here back to there. Angles around the point, the angles add up to 360. So that's why I could confidently say 90 plus 3x plus 5x plus 3x plus 30 is equal to what? 360. What's the reason? Angles around the point. So I've given a reason because they wanted reasons stated. Then I solve for x. This here should be straightforward because in term 2, you did solve for x in grade 9. So you guys should all be good at this point at solving for x. If you are still struggling with solving for x, then it's going to sabotage you getting the answer here. You add the like terms for x on the left, you transpose, you move the other values. 30 goes over, becomes negative. 90 moves over, becomes negative. You add, you subtract, you get the answer, you divide by the coefficient of x, you get x is 30. Then after that, remember they wanted the size of who? GEF. You have the size in terms of x, but now you can go and substitute the value of x in the place of x. X was 30, you substitute. 3 times 30 gives you 90, plus the 30 gives you 120. So the size of GEF is 120. How beautiful, how beautiful, how glorious, how complete. I think before I leave, because I have to go now very soon, right, let me just do one more question so that I can bid you guys farewell and say goodbye. Thank you so much for joining in. I know some of you have to leave as well. Thank you for joining in. It was a beautiful pleasure to have you. All right, hopefully we can see each other again. But let's just look at this one. In conclusion, in the figure below is given triangle ABC with angle A 50 degrees, angle B is 55, and angle BC is extended to D. BC is extended to D. So that angle C2, here's angle C2, is 4y plus 5 degrees. Okay. I'm going to do one parallel line before I leave. Oh God. Calculate with reasons the value of y. So that's 50, that's 55. That is C2. What relationship exists between this angle, and that angle? This is called an exterior angle. It's outside, but we say it's an exterior angle that much more because BC, which is the side of the triangle, has CD extended. So this CD is in line with BC. When CD is in line with BC, then this means this is truly an exterior angle. What do we know about the exterior angle? It is equal to the sum of the two interior opposite angles. So you see these two? They are basically pointing, going towards what? C1, and outside there's the exterior angle. So what we can say is that 4y plus 5 degrees, which is the exterior angle, is equal to 50 degrees plus 55 degrees. Reason: exterior angle of triangle. 4y plus 5 degrees is equal to 50 plus 55. These are the two interior opposite angles, and they are always, the sum of them will always give you the exterior angle, as long as this angle is an angle formed by the same side of the triangle that you are looking at. It must be in line. It can't be at an angle. No. It must be in line with the side of the triangle to be termed as the exterior angle. Now we can solve. 4y is equal to 50 plus 55 minus 5. Then we have 100. Then we divide both sides by the coefficient of y, which is 4. So that means y is 25 degrees. Okay, that sounds simple and straightforward enough. I think. And then before I leave, we have angles on a straight line here. Hopefully you guys can see. Calculate the size of x. Guys, angles on a straight line. We have x there, we have 112, we have 20. We want to find the value of x. So you know, guys, do these complete a straight line from here to there, from there to there, back here? We are on a straight line. These angles share a common vertex. That's why we call them angles on a straight line. So when we add these angles, it should be equal to 180, and we can solve for x. Our reason will be angles on a straight line. Okay, I just want to do that quickly. Angles on a STR line. Then you can solve. Straightforward. I am not going to do the calculation. I'm sure you guys can. All right. I just want to show you statement, your reason, you can then solve. All right. And I think really and truly, guys, I've helped you quite a bit. Unfortunately, I'm going to have to bounce. I have to leave. Unfortunately, that's the unfortunate part. But it was good. 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 I'm sure, raw God, just before I leave you, why are A and B equal in the diagram? Why are A and B equal in the diagram? There is A, there is B. Raw God, you can help me out. A, alternate angles, B, corresponding angles, C, vertically opposite angles, or D, co-interior angles. So why are A and B equal? Very good, raw God. And then what's the right answer there? Then I'll leave you in peace. Thank you so much, raw God. Have a good one. Thank you, guys. It was nice. I have to leave now. Goodbye. Bye-bye. Bye. Bye. And please, you can more than welcome to send me a message if you want to ask about any further questions related to anything. But I go live in the mornings, but just before I head off to work. So guys are more than welcome to join. Thank you for the follows. Thank you for sharing the live, and thank you for everything. I'm going to have to leave you. Goodbye. And don't forget to state the lines that are parallel whenever you are doing questions, okay? Don't forget to state this, okay? Don't forget to state the lines that are parallel. Alt angles. This line is parallel to that line. Don't forget that. If you say co-interior angles, don't forget to state the lines that are parallel. If you say corresponding angles, don't forget to state the lines that are parallel. Goodbye.